right, we're going to look at factoring now. This is a pretty important item. We're going to use it a lot in this unit, and then we're going to use it in the next unit as well, or the next chapter, unit, whichever. Factoring. There is a process called factoring, but the key phrase or word in there is this idea of a factor. If you remember, a factor or factors are things that are multiplied together, right? That's the simple way of saying it. Things multiplied together. All right, so if I see that two things are multiplied together, I can say that they are factors of. So for example, 2 times 3 equals 6. If that is the case, then the factors are 2 and 3, because those are the things being multiplied together. Now we're going to get a little more interesting than just straight numbers here, but the idea of factoring, when you are factoring, it's the process of writing things out like they're being multiplied. So it's the process of writing these two things, these factors. It's the process of writing out the factors. It's actually the exact opposite of multiplying. It's the opposite of multiplying. When you multiply, you take two different factors and you get a product. When you factor, you start with the product and you write out the two factors. It's the opposite. Makes way more sense when we do an example, but that's the background. I can ask you to factor this. Now, there are multiple methods of factoring. The one that you're going to recognize the most, or the one that you should start with, is the greatest common factor. Greatest common factor, otherwise known as GCF. So I could ask you to factor out the greatest common factor. Now, there is a quicker way of doing this, but I'm going to do this really with the core basics. To find factors, remember, you could use a factor tree. So this is a term, this is a term, right? So I can look at the factors of 15x squared. Well, 15 can be broken down into 3 times 5. X squared, you know, is x times x. So I could rewrite this as 3 times 5 times x. That's what this is. Minus, and then just this 3. So I could ask you, what are the common factors between these two terms? Well, the only thing that's common is a 3. So if I pull out that greatest common factor, that means I still have some stuff left. From this first term, I still have this. So I have 5xx, still have the minus, and when I pull out this factor of 3, I am still left with a 1, because in theory it's times 1. So notice that I have two terms inside, and I have these. Let me write this a little better. You see this 5xx? Can I just go ahead and write that as 5x squared and bring that out? So if you ask me to factor this expression, this is the answer right here. How do I know I'm done? Because I see that I have two things multiplied together. 3 times this whole thing. Now, I could check this by checking out to see if when I multiply this out, do I actually get this original thing? So the opposite, like I said up here, it's the opposite of multiplying. So if I want to see if that's exactly right, I can just multiply this out to make sure. So this is just distribution, this and this. 3 times 5x squared is 15x squared minus 3. So no matter what, if you can't multiply it out when you're done and get the original, then your factors are not correct. That's the idea of pulling out the greatest common factor. Let's do another example, a little bit more interesting. What about, say, 15 u v to the 6th minus 10 u squared v to the 5th. All right, now if I look at the numbers, I'm going to do this kind of quickly. I see that for the numbers, I can pull out a 5. For the u's, I can pull out 1u. And for the v's, I can pull out 5 of them. That's common. That'll leave me with 3v minus 2u. Did that quickly, just filling it out.